Danny, it's all yours.
Thanks, Lou. The interesting thing, I think, is calculus in R.
Are you turned on, by the way?
By you always. But,
I've got to shut up.
so I'm going to talk about teaching, which is not always a very good thing to talk about. How many of you teach here or somewhere? What kind of classes do you teach?
R.
You teach R? Who said?
I teach it for software carpentry.
Okay.
Computing stuff, version control, R, Python. So.
I teach grad students in
How to use R. Okay. Anyone teach undergraduates? What do you teach them?
Intro statistics.
And what do you use for software?
Oh, they don't use software.
Okay, good. So that's actually the most common software to use in teaching introductory statistics across the country.
R code, and that scares them.
Yes, code is scary. Anyone else teaching undergraduates? Uh-huh. And you wouldn't use R?
I wouldn't use R for proofwriting. I don't think so.
Okay, well, that's fine. But what do you use?
I tried to use R once students revolted.
R is a tool, and students are revolting. It's true. But what did you use?
No, I use R.
Oh, R. Oh, I was wondering what you're using. Okay. All right. Well, enough with that. So I'm going to talk to you about some ways to use R. They're not very profound or esoteric. And this is a tutorial. And so I looked up what a tutorial was on Wikipedia. And it's supposed to be interactive and teaching by example. So I'm going to make you work a bit during the course of this. And if you have R on your desktop, that's fine. If you don't, then use the our cloud server that Drew set up. So if you can get access to that, or if you can't. And many of you will know very well better than I do, the things I'm talking about. When it comes to it, then your job is to help other people when they have to do stuff. Okay, so if you already know it, please help people out. And today I'm going to talk about teaching introductory students. And I guess at the end, I want to kind of direct you to building a lesson in R using some of the techniques that I'm going to talk about. And tomorrow, I'm going to misspell possibilities, I see. And I'm not sure what I'm going to do tomorrow, because it depends on what we do today. So first, many of these you've seen, some resources for teaching with R. And then I'm going to list some principles which you might well disagree with, or which might be wrong. And those principles apply to many different software packages. And then the main thing I'll do is try to illustrate those principles with R. Okay? And you've already seen RStudio. Who had never seen RStudio before Drew showed it? Okay. So it's really kind of taken over as the IDE for R, and there's several good reasons. You've got to see the cloud version. There's a desktop version. And there's a lot of convenient aspects about RStudio that make it nice in doing your day-to-day work. But to me, and for teaching, the big stuff is that it has an editor that connects to R. That's not saying very much, right? All the R GUIs have had some kind of editor, but not typically very good editors for talking to R. And it talks to other software. So it'll talk to LaTeX. I find that too hard for introductory students, and often too hard for graduate students and postdocs and faculty. So I'm going to show you something that is really easy and really effective, something called Markdown. And I'm just interested, who's heard about Markdown? OK, so half of you. Great. And then for the instructor of a course, RStudio has nice project organization and collaboration support. And Drew, was it you who talked about GitHub? Who talked about? And it plays nicely with Git and GitHub. OK. And I guess in short, if you're going to have a class of students, set up an R server. Have them work on that. It saves all kinds of hassle down the line, including dealing with the 50 different varieties of operating systems that your students have. If they have Facebook, which I think is a given, then they can run RStudio on the browser on their computer. And it allows also instructors to sort of access student sessions, although that feature could be improved. There are some cons, but they're not major cons. The biggest one, I think, is the confusion students have with dealing with files, since the server is another computer. But there are easy ways around that that work even better, that work also on the desktop. Okay. So Markdown, for those of you who haven't seen it, it's like LaTeX or something like that. It's a markup language. It's very readable. It has a very simple syntax, and you can learn it. If you haven't done it, you're going to learn it in just a few minutes. And it compiles to HTML, which means that all of the infrastructure of the web that's oriented towards HTML, putting YouTube videos, embedding YouTube videos, embedding Java apps or something like all of those things you get for free. And if you need to print it out, it will also compile to Word. Then you don't get the web benefits. Or it'll compile to PDF through tech. Okay? And you don't need RStudio for this, but RStudio has a nice connection to it. Right? And you as instructors, you're not doing just one thing. You're switching between contexts. And so you're teaching a class, then you're going to this research project, and then you have to revise a paper that you're working on collaboratively, and then you teach another class, and you have this brilliant idea, and so you want to try out this epiphany, but you don't want the epiphany to make it into your paper. It's going into the next paper. And so RStudio has this idea of projects. Again, I'll just ask, who's used projects in RStudio? Not so many. Very easy to use, and I'll show you a little bit of that. But it's a way to have multiple contexts with their own documents and their own workspaces, and to be able to switch back and forth between them. So not everything is your file management. And then other useful tools for instructors, not so much for intro students, Git and GitHub, and then various R packages. And one R package, oh no, now we're going to do Markdown. OK, so I would like you to write a Markdown document. And I'll show you how to get started doing this. And then you'll do it and talk to your friends, which is going to be very short. So you could write a biography. You could write a biography of yourself, like these NIMBioS blurbs that are on the TV. That would be great. But I want you to write some document. I have an example here. And to do this, I'm going to go to what you've got, if I can find it. That's what you've got, I think. Right? And let me make it a little bit bigger. Oh, now I don't use this very often. Version control. Where's preferences on this one? Any hints? Preferences. I want to set the font size. Okay, I'll just do that. Okay, this is what you're going to do. Go up to the File menu, as you would with anything, and there's a New File item. And there's all these different types of new files. And the editor sets itself up differently for these different files. If you're just writing an ordinary R program, you might write it as an R script. Later in the workshop, we're going to be talking about C++. This is nice integration with C++. But the one I want you to do is R Markdown. So select that. Oops. And oh, OK, that's something I didn't anticipate. We're going to have to install a package to do this. Can you do it for everyone? Is that OK? And I'll bluff. So you know NIDAR. Yeah. So if you could install that, that'll be great. And don't worry right now. I'm going to show you how. We're going to start with writing Markdown. And the RStudio people, helpfully for the very beginning, but unhelpfully when you get used to it, they give you a complete document in Markdown, and you can compile this document to HTML. And it includes various R commands in it, which get integrated automatically into the document. We're not going to do that now. We're going to do that in a little bit. And what you do is to write your own document here. And I'll start to write one to give you the basic syntax. Any ideas? Did someone just want to throw out something for us to write? So who to write a biography about? Come on. Abraham? Okay. Okay, so here's a title. That's the markdown for a title. And let's start out with a section. Oops, 2 hashes. Early days. Who can tell me? Is Abraham Lincoln from Tennessee?
No, Lincoln was born in
Indiana?
No, he was
Okay. And was born, it's just in Illinois.
Wasn't he born in Kentucky?
But some people say Kentucky. And others say, what was the other one we had? Indiana?
Yeah.
Say Indiana. Does it really matter? And another section, the log cabin. This is a political thing that comes from the Republican convention in 1860 in the Cooper Union, where they painted Lincoln as this log cabin character, rail splitter, right? And he was, but it's a political thing. Any luck with NIDAR? It's installed. So what I'm going to do is, I don't know whether you'll have to do this. Go to the packages, and that's a tab over on the right on this one. And okay, how am I going to do it? I'm going to do something else because I didn't think ahead. This is not how you'd normally do it. I'm going to give a command, require NIDAR. Let's do that. So you do that too. It loads this very helpful NIDAR package in. And then I'm going to save my Abraham Lincoln. And this is on the cloud, on whatever computer it is on the cloud. So I'll just make something. Oh, I don't put spaces into any. And I'll save it as Lincoln. Good. And now I'll press this button. Yeah, okay. Just a second. Sorry. You see, I wanted to close it down, so maybe it would reload the package. And it's being a little bit slow. I'll switch to my desktop in a minute, but this should be fine. Let's see if that's going to work now. That's better. OK. So one of the nice things about RStudio, just to mention it, is that here I turned it off and on again, but it kept my editor there. And you can have many files in the editor. That's just a convenience. OK, so you can see the syntax. There's sections, right? How do you make a subsection? 3 hashes. How do you make a subsection? There you go. You got it. All right. Look at this carefully and tell me how to make a bullet list. You put a star and a space. The spaces are important. A star and a space. And then you can start one on a new line. If you want it to be numbered, that's no problem either. You put a 1, and then you're welcome to put any numbers. You're welcome to put 59. But there has to be a space. And here, I'll compile it. Oh, I see. It came up here. So there it is. And this is trivial, right? But it's going to be useful. A couple of other things I'd like to have you do. I want a link. So Wikipedia, someone suggested. Yeah. OK, let's do that. Abraham Lincoln, Wikipedia. I'm going to grab that. Right? If I have the URL, here's how I'll put it in. Oops. Put it into Markdown. If you want something real, then look here. Okay, what's the syntax for putting in a link? The brackets around the text, which is going to be the link, and the link in parentheses. It has to be parentheses, so it's strict about this, but that's not so hard. I think I want to get an image in here too. So I'll just get one from Wikipedia. Let's find one that I like. That's not so good. Log cabin. I think I want a log cabin. That's going to do me. Okay, so this one's coming from Wikipedia too, coincidentally, and it's really big. Okay, bad choice, Danny. But there's all sorts of stuff on the web, including systems being a little bit slow, including stuff that you make. Right? Your figures don't have to reside on a disk in your computer. Your figures can be in the cloud, and if you use something like Dropbox or many things, you can put them on a web server, so you can get the link to them. And that's the best way to include static figures like this. That's too big for Lincoln. Well, oh, that looks good. Be small. Yeah, that's nice. Okay, so this comes from someplace I've never heard of. Anyone know that place? That's fine. Log cabin. So here's the markup for putting in a picture. I think you can really put anything here, but I'll put log cabin. And I'll put the link. So now it's just a link, and then a little bit of syntax. Do that is what the bang means, and I'll compile.
The blue is what would go there if the link didn't exist.
Oh, I see. The image doesn't show. Oh, and I'm not used to doing it this way. And there it is. Now, one thing about this HTML file is that it's complete. So you can send just the file. The image is there. You can send just the file. Or if you want to make a snapshot of something at a given time, the documents you make will reflect the links as they were at that time, or the pictures at those links as they were at that time. Okay? So that's Markdown. I want everyone just to make something. It doesn't have to be a big deal. Make something, make sure you can compile it to HTML with that knit button. And I'm going to wait until you've done that. We're going to do that in a little bit. All right, but that's the main reason to do this with R, because you can integrate R into the documents. Yeah? Oh, yes.
Right where you're standing, box the command prompt into the
That's very polite to say I'm in the way. If anyone's having difficulty, ask your neighbor or ask me, or we'll figure it out.
having trouble.
Oh, that I can't. I did this one.
Oh, you did. All right. Thanks.
Oops. Where is it? That's what I needed. Does it work? Did someone get it to work?
Yeah, my RStudio wasn't working, but now it's working.
And so can you get an HTML document? It'll show up in the browser tab next to the RStudio tab. I like the desktop one better because it does something nicer.
What HTML version? I don't understand.
This is HTML now.
Okay.
Yeah, so you've
What was it doing otherwise?
what you were writing in Markdown, and then that compiles to HTML. So the hashtags aren't there, the bang square brackets aren't there. They're replaced with things that matter.
Okay.
So this is it. It's not hard. You're saying, is this hard? No.
No, I was just trying to understand if there was a distinction of what would come up in one thing versus something versus the other.
And it's a little bit odd because you have these, RStudio puts them up in these different tabs. So that's not even it. Well, I've lost it, but don't worry about it.
Can you show everyone how to get to a quick reference?
Yes, that's an excellent idea, and I have to find which tab I'm on.
I think it's RPubs.
No, that's not RPubs. That's something else. That's mine.
Wait, to the right.
To the right?
I think it was in the...
Oh, Danny. And, you know, it's important when you're teaching with computers to give yourself a break, because you're going to screw up. And I'm screwing up more and more these days, but you're going to screw up. And I'm just looking for history. Let's see what we got. I'm looking for the RStudio. All right, I'm going to switch to my desktop just because I don't want to waste your time. This is not anything fundamental. It's just that I know where my desktop is. Okay, so who was the person who made that helpful suggestion? What was the suggestion?
I would show how to get to the quick reference.
Okay, and I think you do that by going to this question mark and pulling down Markdown quick reference.
Yeah.
And then here you go. This is pretty much everything you need to know about Markdown. It's a very concise language. It is helpful to know that you can also put LaTeX equation markup in trivially. So you just say $, then no space, start on your equation or formula, close with a $, and it'll compile, and it uses mathjacks for those who care.
Yeah, there's like a weird bug with Chrome node that will crash the Chrome browser if you use the mathjacks in LaTeX.
Well, let's just see.
They're working on it.
They're working on it?
They know.
That worked last time I tried.
Yeah, it's like it's an update thing. They're working on it.
I didn't change anything. It just became like that. I don't know. Maybe you.
So it was a pretty funny thing because it was just like Chrome.
So even if the thing doesn't exist, well, I guess that exists.
Oh yeah. Yeah.
See, it'll put it up, translate the LaTeX into what you expect for typesetting. Okay? So that's helpful for people who do math type things. All right. Okay, people able to write this? I'm going to move on. Yeah. So it's good question. It's best to save it without any extension file, and RStudio will put RMD on it, and that's a nice one to use. All right, let me try to get to my slides. Okay. There's a log cabin. I don't need that anymore. There we go. Okay, so now you've done that. So this Markdown is actually a very useful tool because you can require your students to write reports in it, and they should be able to do it. There's a reason to do that, and there's also a system for publishing the reports that's very easy. I can show you later on. So they can hand in their stuff in a very easy way. All right, and then these are just directions on how to compile the document. You don't need to know this now, but if you don't have RStudio, you can still compile the RMD document. And then the last resource I'm going to point you to is what's called the Mosaic package. And Mosaic is an NSF-sponsored project, the goal of which is to try to tie together statistics and calculus and computation and modeling. So rather than teaching people integration by parts, maybe we should start with teaching them how to build a function you might want to integrate. All right, so this package is called Mosaic. And Drew was nice enough to install this, so you don't have to do this. But if you didn't have Mosaic on your system, but you do have to say load Mosaic. So here, just do this. Oh, because I'm in the screen viewer. That's why. So you can just say load Mosaic. Huh. Oh, not load. Yeah, you see? Library. Okay, and then you can do help Mosaic. All right, and I'm going to show you some of the features that were built into this. The point being to make it easier for students to start with R. Not like R Commander does, which gives you a kind of GUI, but by simplifying the syntax of operations that you do in R, and by making the syntax consistent. All right, so let me go back to my... One thing you should not do when teaching is jump around between screens. Okay. So I'm going to give you a few principles. They're really reflections. They're ideas that I have. And they might be wrong. They're certainly inconsistent. You have to use common sense when applying them. I don't think any of them are really absolutely, you're doing the wrong thing if you don't do this. And here they are in brief, and I'm happy to add new ones in. But you're teaching students, you really need to keep it simple. They don't know as much as you do about using R. And you should teach one thing at a time. And I'll show you an example of how we teach many things at a time and why that can be confusing. Is collaboration, do you say to your students it's important to collaborate? Would you tell people who are going out into the workplace that collaboration skills are essential? Yes, okay. So, in our teaching, we should give people collaboration skills. And traditionally what we do is we say, write your report together. Come back when it's done. All right? I think it's really important for you to model for the students a professional workflow, the sort of thing they would be doing if they were you, if they were doing serious research, or if they were writing a report that they needed to stand by later on. Don't use that four-letter word. It just signals the students that something is not going to work out for them. And do give them some immediate gratification. Now, it's silly, but when you hit that knit R button and you got an HTML document, was that gratifying? It doesn't take much to gratify students. Oh, I can do that. It's like Hello World, but with pictures. And then give students a working scaffold. I'll show you that. I'll elaborate on these. Make the technology you're using central to what you teach and how you teach it, and then build on what students already know. Right, so those are the principles. And when I say keep things simple, Einstein also said this. So I think that's the authority. That's as much as I'm going to say about why you should keep things simple, because Einstein thought so. OK, first thing. I teach statistics, so accessing data is important. You may be teaching other things. In probability, you may have other functions that are important, or something of that sort, simulations. All right? Make it easy for students to get to, I'll just say, the data set, or the data sets. How do you currently make data sets available to other people? I'm sorry. Does anyone make data sets available to other people? You put them on a website. And that you could be in the public folder in Dropbox is a website. Does that sound right? Other things people do?
GitHub, email.
GitHub, email. Tell me more.
Well, that's what a lot of people do.
You could email this stuff to your students. Yeah, I just can't imagine that more than a small fraction would do that. So, as Lou said, have a repository. But even better, it's really simple. You can go back and show them how to access data over the web, or clean data, or scrape data, whatever you want. Let them access it just by name. Today, we're going to work on the data set that Galton collected in the 1880s about heights of children, adult children, and their parents. So I have that data set for you. I assure you this is not how Galton entered it into his computer. Right? It's undergone some revision. And for those of you who know what this means, I think it's a really good idea to develop a package for your course. And if you can do this, and it's not that hard, and then it's easy for you to update the package and easy for students to get the updates within R. So that gives you a great way to communicate with students and also a great way to document what you're doing in the course. And then, so keep it simple. Data should not be hard to get. And then in the Mosaic syntax, I'm going to show you some of what goes on. OK, so I'm going to ask you, how would you calculate the mean of a variable? There's a variable height in Galton. I saw a pen here before. Oh, here. How would you, in R? So I want to know the mean height. And the data set is in a data frame called Galton. And it has variables height, the mother's height. This is of the kid's mother, father, sex, a few other things. If you just do str Galton, you actually have it now because you loaded that Mosaic package, or you libraried that Mosaic package. So I want to compute the mean height.
Mean, parentheses, Galton, dollar sign.
Anyone disagree? Or anyone have a better way to do it? OK. Never attach. OK, look at Drew. He's nodding. No, that's a principle that is not, I'm not going to argue with you about it. That's just right. Attach makes your workspace sequence dependent. It's hard to restore it. You could restore it in ways that your commands still work, but they give you something completely different. So don't do that. But then you would just say mean height. That's what you like about attach, is you get to say attach Galton, mean height. Is that what you like about it? Because mean height is easier than mean Galton dollar height. But any other suggestions for how to compute the mean? Yeah, you could do summary and look at the right entry to it. I mean, you could do sum and divide it by n, but that seems silly.
Galton dollar sign height is x, mean x, which refer to break into two sides.
OK. Yeah, you could do that. And then we could elaborate and do it in 3 and 4 and 5. OK. All right, let's take this. I don't think this is the best way to do it. But all right, now, next task. I want you to calculate the mean height for the different sexes. There's 2 sexes in Galton. Mean height for the boys, they're kids, and mean height for the girls. M and F are the codes used in the data.
So the same, but just in brackets of the height, sex equals M.
So you would say Galton, bracket, like that?
Dollar sign height. Bracket, sex equals.
Here's for the ladies, like that? And then mean.
Yeah, because you have to do Galton dollar.
OK, see, I think you have to do Galton dollar sign sex.
Yeah, you do, yeah.
For learners, has anyone suggested just running some
And there are things like summary. I'm going to show you another way to do it. But I just want, you could aggregate, right? I just want to show you that these things, I mean, if you're a student, why is it a bracket? Why isn't it a parentheses? Why is it equal, equal? I mean, those are nice things to learn. But at that point, you're teaching students about programming and indexing and Booleans rather than teaching them about heights of kids, right, and how to analyze heights of kids. OK. And then if you did this, how would you find the residuals from the group-wise means? You want to say something about the mean, those means minimizing the sum of square residuals.
Galton $height minus mean Galton $height would vectorize it across all.
So this is your proposal? That's a good proposal. Like that. OK. Let me introduce the mosaic notation. All right? And there's no reason why R couldn't have been written this way. A lot of R was written this way. In mosaic, what you would do is you would say mean of height. That's for the attached person. I don't, what's your name? No. Good. I've accomplished my purpose. All right. Mean height. Ready? Broken down by sex. Right? If you were doing LM or GLM or something like that, you'd do that. That's built into R. And then you'd say data equals Galton.
Which is very similar to aggregate height as a function of sex, data Galton.
Right. It's very simple to that. But we wanted mean to work this way. Now, mean is a difficult one because it has to also work the way everyone expects it to work. So there are some things we can't do with mean without breaking it. But you could say mean height without the tilde sex. You could do that. You could say mean height and sex, break it down by sex, and the entiles of the mother. All right, so that'll give you the groups broken down by males and females for different class, the first tercile, second tercile, third tercile, right? And this is a notation that can be extended. And you could use plus here, too. I'm just in the habit. And that notation is exactly the same as you're going to use in LM, right? And so if you're going to teach means, you might as well set people up to do stuff with proper models, right? Group-wise means, sometimes useful. But you can go further than that. You'll see later on, or no, tomorrow probably, that we've introduced a function that's like LM, but does means. I would have liked to override mean to do this, but that would break what a lot of people do. How do you find R squared of a model? R squared is always of a model. Model summary? Good. Here's what you do. First, build your model. And I'll build it stupidly with MM. Height tilde sex, data equals Galton. All right, now I've got a model. And now I'll say I want R squared of that model. And if you're asking, how can you do R with categorical data? Well, of course you can do R with categorical data. Right? Galton didn't know how to do that, but we know how to do that. Right? So operations that should be simple are simply expressed. You can use R squared on models produced by LM, by GLM, and so on. Right? So you're using the same operations and the same syntax for many different kinds of operations. That's what I just showed you. And that syntax also applies to graphics. The lattice people put that in. That's not the mosaic thing. And it's a little bit inconsistent, but I'm going to suppress that. We've been working with the lattice people. It's the same notation. What you want to do, there's only about 10 or 15 things that you ever want to do. All right? What the relationship is among the variables that you want to study, where the data are coming from. Sometimes there's other arguments, right, for quantiles or such. And this is what I just said about means. Now, here's the thing. Students come into statistics, And it has absolutely nothing to do with the math that they studied in high school all those years. Right? What do students do in high school math? They do algebra. Okay, they don't want to do that. Right? They plot functions. Right? And in statistics, we're showing them numbers. Well, you don't need to do that. Oh, I didn't punctuate this right. Here, I'm building a model of the height as a function of the mother's height and the sex. You see there's an interaction there if you know how to read the R syntax. Right? Interactions are not difficult things. All I'm going to do is extract the model function. I could extract the residuals. I could extract R squared. I'm going to extract the model function. And then I could evaluate that model function in a way that kind of makes sense. What's the effect of 1 inch change of the mother's height? Well, I don't know, but I'll just try out 1 inch for women. Is it different for men? You could try that. Right, the function notation is more familiar to the students from calculus or from algebra. Admittedly, they've never seen anything like that in math. Right? They've never seen a categorical input to a function. It's always some real number. Right? And then it's not a very good graph, but then you can graph these things. So here I want to make a plot of the interaction plot. Those slopes are just a little bit different. But all I'm doing is plotting out the function first for the women, then for the men, adding one on top of the other. Okay, and these are done with lattice graphics. So for those of you who know, we didn't want people to have to write lattice routines for doing this thing. And we do calculus in R at Macalester, and there's no reason not to use R for calculus, especially for introductory calculus, which is all that most statistics students and biologists take. Not you all, but all that most of them take. So you want a derivative? Right? Here's the expression. Oh, x is the input. Right? You want the antiderivative? There it is. Now notice what it returns. It returns a function. An antiderivative is a function. A derivative is a function. Right? So they're getting back a function that they can do anything with. And also, we have features for model fitting, linear, nonlinear parameters, for solving differential equations. Why do you want to solve differential equations? Well, you might be interested in the phase plane in biology, or you want to show logistic growth. They don't have to know much about differential equations to do this. And we talk about other things in the course as well. We wrote the symbolic integrator, which I'm very proud of, but it's crappy. So it does some things right, but other things, this one has an analytic form that's not very difficult. When it can't figure it out, it returns a function. And it's only if you look inside the function that you see that that's not a formula. But it works like every other function. You can evaluate it, you can plot it, you can overlay. It's just an ordinary function with some ugly stuff inside that we ought to be hiding, but just a regular function. So analytic integrals and all other integrals are not that different. Okay. So we talked a little bit about sharing and distributing files. What's hardest for everybody is to have students copy files to their own machine. So you email it to them, say, and then they put it on their own machine, and they forget where they put it. All right. What's easiest for the instructor? I like Lou's idea. Put it on a website. What's going to be easiest for the students is to put it in a package. All right. But I'm going to show you some other ways of distributing files, and especially dynamic distribution, dynamic access to files. Okay. So no, I've got something out of order. Just a second. There we go. So the dynamic access to files is one of the things that supports collaboration. Right? If you have the same files to work on, then you can collaborate pretty easily or easier. What do you all use when you want to collaborate in that modern sense? I'm sorry. Do you work with other people? And what tools do you use to support your working with other people? GitHub, okay? It's a great tool, but there's no simultaneous editing with GitHub, right? There's a push-pull thing that takes a little bit of discipline, but it's what I use for, right? And for sets of documents, as in software systems. There's no choice but to use something like Git.
So do you suggest then that like they curl something so that you could have a dynamic document in Google Docs or something like that, and then they're going to curl down? Is that basically the idea, that they're going to pull from that?
Do people use Google Docs for collaborative editing? Why didn't you say that? Is there something that's indecent? It's not like attached, sorry. Is there something indecent about it? Have you ever tried to use a Google Doc with R code? You basically have to cut and paste. Not so nice. What we really need, let me see if I can get this thing to come back up. All right, that'll show me to enter full screen mode. What we really need is a shared editor right here, where I could say, OK, here's the ID of a document I'm editing, and we bring up Google Docs there. There's nothing undoable about that. It just hasn't been put into RStudio yet. And if you want to write to the people at RStudio and say, that makes a lot of sense to have something like that, I'll encourage you to do that. But meanwhile, I'll show you that it can be done. So I'm going to skip to this. You don't have to do the install GitHub, I think, because, Drew, you did this already. So do library just NIMBioS. Library just NIMBioS. All right, all caps, the way I did it. I didn't know that the lowercase is significant. So what you're doing is loading in another package. It's a package that I built last night for this tutorial, just as I would build a package for a class, although I wouldn't do it the night before my course started. Are you able to do that, library NIMBioS? In quotes? OK. Now, give these two sequences of commands. Exactly those. I'm not going to do it, because then you wouldn't be able to see the commands. I'm just going to copy that out. Does everyone have that? If you spelled something wrong, it's not going to work, but I don't want to dwell on it. Oh. So don't do that. Don't give broken things to your students. That's a principle I wanted to illustrate. I got this. Did anyone else get this? It's not. It's a public.
No, I mean,
but that's only for the package. Oh,
I
wrong one.
downloaded the package, and I can get help on the package, and I see that there's something called Collaborate that's supposed to be in there, but it doesn't seem to recognize it as a function.
Oh, you know what it might be? Our curl. Is our curl installed on the server? I don't know what it is. OK, so that broke. That didn't work. Sorry. But the principle here is, did anyone get it to work? Yes, thank you. Would you write something, please? What did you write? Line 7. It works for me, too. OK, good. And then here, you tell me what. Well, you'll see it on the screen, right? I can write.
Oh, there we go.
Who has a there you go?
Oh, I just said there you go because it seems that I maybe had to load the. I mean, install from GitHub. Yeah, needed the library NIMBioS as well. So.
Yes, OK. So the thing is, this is not really what I want. What I want is this integrated with R. But this is like Google Docs, collaborative document. And when you want to read it into R, you can just press that button. I really want someone to improve this for me, please. And you could say F capture. Right? And now I have the contents of that document in R. I could similarly run it, source it, if you know about those things. I could run knit on it. So it's one step away from having what you really want. Pressing that button is a pain. Being in different windows is kind of a pain. But it's closer, and it is certainly, if I can do this, then the people at our, I can't do anything. Then the people at our studio can do this. Okay, so why have all my, what's going on?
Well, yeah, somebody's editing it, and they just said, I can write whatever system sudo remove
Thanks, Drew. Now, one thing I've done with this doesn't really have to do with R at all. You know, I typically spend the second day of a class asking students to introduce themselves. Not the first day, because that's not what the class is about. And then I said, OK, I want you to introduce yourself. Write something down about yourself here. And you have 40 students clicking away at this thing, and they sort of self-organize into a style for describing themselves. They see what the other people do, and then they modify their own. It's really pretty impressive process. And this product that I'm using, I didn't write the product, supports pretty large sets of editing. Similarly, you could edit Google Spreadsheets collaboratively and read them into R. And I'm not going to do this now because Google broke what I have, but it will be fixed again. It's always an arms race. So let me move on to the last subject for today, and then I'll have some of these for tomorrow, or you can tell me what you'd rather I talk about tomorrow. You've got this technology which does calculations essentially infinitely fast on the scale of things for introductory statistics, and yet we use it to do the stuff people were doing in 1920. Has anyone used t.test in R? Does anyone do, what other tests are there? Chi-squared? Okay, I mean, why chi-squared when there's a Fisher exact test to be done? But use chi-squared. And those are nice, convenient R operators for performing the sequence of steps that you would do by paper and pencil. And those methods were developed for doing it in paper and pencil. But now you don't have to do it in paper and pencil. And so if you can write down doing something, all right, so here what I'm going to do is, you have to know that this means as models. All right, so I fit a model, and then I'm looking at the sum of square residuals. All right? Oh, I'm going to fit a model. Oh, it didn't punctuate right. Not using the mean, but using the median. I think that's better. I would only do this if I wanted to show what least squares is about. And here's the sum of square residuals. Which one is better in terms of the sum of square residuals? The which one? The first one. It's not much better, but it's better. And you could do sum of absolute values of residuals and so on. You could even have them make a function where they just make up numbers and say to the class, OK, here's the statement for doing it. Each one of you make up your own numbers and tell me what your sum of square residuals are. Right? Then they see that they can't do as well as the mean for least squares. They can't do as well as the mean. And so here it is for this one. What was it before? 56, 70? 56. It's not much worse. Right? And that itself can tell you something about the standard error of such things. But that's another thing. All right, last thing. Again, how to use technology to teach. So who's taught a statistics course here, an intro statistics course? OK. Do you teach the p-test, difference in proportions? Where you're looking at the fraction and the standard error? Yeah? The z-test? No, but you do. The t-test? One-way ANOVA? Why do you say not really?
Sometimes we get to it.
You mean it's at the end because there's only so much time to cover this stuff. All right. Now the thing is that all those tests are the same test. So why do we do it 3 times? Because we think repeating ourselves is good? Well, that is good, but it's better to repeat yourself with the same thing instead of with different names each time you do it. All right? So I'm going to show you support for teaching the the basic concepts of inference, rather than the algorithm for doing a t-test, the basic concepts of inference. And the students can get the basic concepts without being able to do the t-test. They can always use software to do something like that. And the basic concepts in statistical inference is a fellow named George Cobb, who's at Mount Holyoke, who likes to describe it as the 3 R's of statistical inference: randomize, repeat, and reject. Right? In order to do this, students need an operation which randomizes. Students need an operation which repeats. And then they need something that corresponds to reject. They never learned an algebraic operation for repeat or for randomize. They learned square roots, logs, all sorts of things. So we write our statistics books in terms of logs and square roots. But they never learned how to do repeat and randomize. So let's do it here. So for randomization, there's 3 functions in Mosaic that are convenient. One of them is resample. And if you wanted to get another seemingly random sample of Galton's data, that's all you do. Same model you fit, same data, except you're resampling it. Students don't have trouble understanding what it means to resample something. All right. And you can do that also for LM. You can do that for anything that has a data equals argument. That's why data equals is in all of the Mosaic functions, pretty much, so that you can apply this kind of reasoning to it. So there's for getting sampling distributions. How about for hypothesis testing? Any guesses? You got 3 things here. I showed you one already. Oh, it's not funny. OK, that's what shuffle is for. And you see the difference? We're not shuffling the data set. We're shuffling a variable within the data set. Right? If we shuffle the data set, we'll just get the same people in a different order. But if we shuffle a variable within it, we disconnect that from that. And this logic works for everything you would be doing, GLM, LM, all those things. It's the same logic. And then RAND is kind of special. And I'll do ANOVA now. So let's say you understand about how to fit a model, which might be as simple as that. And now you propose to add some new variable to the model, some additional factor. Family is the code for which family the kid came from. There's typically 3 or 4 or 5 kids in each family in Galton's data. And you can see for yourself just by operating on Galton, because you have it. All right. So I can build these models, and then the question is this one better than that? Could you do that calculation and tell me what you think? And 2 minutes. Students like R squared, and they like it while you're doing this. And they like it a lot when they see they can add in more variables to a model or more terms, interaction terms and such, and get R squared to be bigger, because their understanding is that bigger R squared is better. And they go to town when you have 20 variables in something. They'll put in 20-way interactions to try to get something out of it. And they really like that. And I think it really helps students to do that and then to see what the problem is. So what did anyone get this far? Let's see if I have it. All right, well, here it is for mod 2. All right. And one thing I had to look at is how many coefficients there are in mod 2. With sex, there's just an intercept in the sex coefficient. But with mod 2, there's families. It's 196 levels, 197 levels of family. So what am I going to do? I'm going to create a world with 196 random things. These should not explain any of height. And I'm not comparing it to mod 1, which is about 0.5. But you see, I got an increase from 0.5 from mod 1. And you can see this does better than that. That's what ANOVA is about, is saying this guy, the actual family, is pulling its weight. Everything increases R squared. Increase it more than junk would increase it. That's the statistical concept. And all those formulas are about how to figure out what junk would do if it was 1930. But we have other ways to figure out what junk would do. And the 1930 calculation is beautiful, but specialized, I'll say. And then here's repeat. All right, so I'm going to look at r squared of some model. I'm going to repeat it 5 times. That kind of repeat students get immediately. There's no accumulator. There's no loop. Right? They don't have to do any bookkeeping in the repeat. And do is set up so that it does the right thing. So depending on the output from the basic thing, do will try to do the right thing and put it into a sensible structure, a data frame typically. All right, so my time, I've overrun my time. I apologize. But I'll pick up on some of these things tomorrow, and we'll do more stuff. I want you to do stuff. I'll pick up on these things tomorrow. But if you'd like me not to, just whisper, and I'll see what I can do to change. And I do. Sorry. OK. Yeah?
Are your slides available anywhere? Are your slides available online?
Are my slides available anywhere online? What a good question. Yes, of course they are. I would ultimately put them in the package so that they would all be in one spot. But I'm just going to show you one other little feature, which is very nice. So come on. Oh, that's not it. OK, Danny. These are actually my slides. I wrote them in Markdown, and I integrated RStudio into them. And then I could compile them. Not going to do that. But when you do that, there's an option to publish to RPubs. So there's a one-click publication. You have to get an account. It's free. It's not hard. One-click publication. And then when you update it, it updates the publication as well. That's not necessarily the best way for an instructor to do it, but for students, that's great. Right? They can always hand things in. Yeah, here. I'm sorry that I'm so inept here. Here it is. There's the link. You can't see it. It's rpubs.com, and then DT Kaplan. And it arbitrarily assigns a hash to it, but
Just send it to Eric, and we'll get it on the WordPress site.
OK, good. I'll do that. Thank you very much. Oh, do you have a question? Or?
It's actually a comment that I think goes along probably with this better than anything else because it's in our classroom. So there's a lot of talk about data, and I wanted to encourage people to think about encouraging students to think about the data life cycle and to think about things like metadata and so on. And there's a really good set of material on encouraging students to think about that through what's called Data One. So I'll write it up there. It's data1.org, which is in part headquartered here and in part headquartered at University of Mexico. And it's got a great best practices. It's an intro to dealing with data for students.
Good. Thank you.